Welcome, everyone. Welcome to a regular series of Eckerson Group webinars. We have a really interesting topic today, data, digital twins, and the road to AI transformation. So with me today to talk about this topic is Rick Hall, CEO of Coginity. It's an analytics software vendor. Rick and I go way back, and he's been on this train of thought with digital twins and AI, and I think he's got something really interesting to share today. So as always, we like to have conversational webinars. So Rick will present a few slides, and then we'll stop. I might ask a question or two, and we'll take your questions or comments, and we'll bring you and your comments into the conversation. So don't be shy. Just add your comments to the chat screen, and I will periodically take a look at those. Just a little bit about Eckerson Group. Yeah, we're a boutique consulting firm that helps commercial and nonprofit organizations get more value from their data. We specialize in delivering actionable data strategies, roadmaps, and governance plans. You can see some of the clients that we've had in the past. If you are interested in getting personal assistance in any of those areas or developing or refreshing your data strategy, that's something we do better than anyone in the industry, we think. We'd love to talk to you. So without further ado, I'm going to pass this over to Rick, who's going to start to introduce this notion of digital twins. But before that, I think he wants to give us a little bit of background where we are today with data and data architecture. So Rick, it's all yours.
Sure. Yeah. So Wayne, first of all, thanks for having me. It's always good to see you. As you were saying, we do go back quite a few years, and boy, the data space has evolved, right? In the time that we have, known each other. As I think you mentioned, I'm the CEO of Coginity, and we, provide data operations tooling, and kind of as we've agentified, added agents and models to our stuff. I've really started to wrestle with, kind of this question of what's happening to data architecture, right? And that's led me down this path to kind of hypothesize this kind of digital twin strategy, which I think is still very much evolving. But I can talk to you about what we're seeing, what we're doing, what I think is the reason for it, and what's happening in the industry. So let's get into it. So, what I think is driving this conversation for me is that, AI in general and LLMs and agents are really changing the requirements for data architecture, right? So, LLMs are not task specific, and they obviously speak language, and they need semantically well-formed data to be effective, right? So if you've got a data model and your table is named cust-001, a language model is not going to know what it is versus its customer. That's the most simplest view of semantics, right? But also, AI tends to perform well on disaggregated data, right? And so, so much of what we've done has been building aggregations for BI. I'm not sure that's really where we want to go with AI. And then agents, as they add this more complex workflow and tools, they really create a real tension between this world where analytics and operations are separate. So we're going to get into that. I think one of the things we have to recognize in the data space is that the data architecture, which we've all kind of lived around for years, which is we have, kind of a set of operational systems on one side, we have some data warehouse or lakehouse or, fabric mesh on the other side, and we update these things overnight. We integrate all the data into one place. It, really has not met all of our needs, right? It's been difficult for companies to unify, their data. The environments are separate. We're moving things in batch, kind of usually overnight. And a lot of times when we pull data out of an operational system and run it into analytical systems, we trip over business rules of data quality. And, we have this very expensive and time consuming problem of, implementing this idealized data warehouse or data platform architecture. Even if we wanted to implement it that way, we haven't always succeeded.
Yeah,
And
it's
you know,
I just gonna insert something here, Rick. It's so true, from an architecture perspective. We've been on the hunt for the silver bullet architecture for decades. And each
right,
architecture from warehouse to data lake to lake house to data mesh to data fabric has been kind of trying to kind of recover from the ailments of the prior generation,
yeah,
and nothing's really sufficed. It's we've gotten we've gotten closer to what we want to do, is delivering high quality, consistent, trustworthy data to users. That's the ultimate goal. But sometimes it's just been really hard to get there, and takes an
yeah,
army of people and
yeah.
millions of dollars. Anyway,
That's right. And it's that army, right? Kind of, if I think about it, I sometimes count, right? And I think I can count 9 generations of data architecture in the time that I've been doing analytics, which probably just ages me. But at any rate, in all 9 of those generations, there's been a central message from vendors that's actually been the same, which is just first move all your data to my platform,
yeah,
and then I'll create this value for you. And that first segment, move all your data to my platform, that's actually a lot of times where the problem is, right? Whether it's
yeah,
a lake house or a warehouse, it's still the same problem. So we have this reality today, right, where companies have a much more dispersed and desperate environment, fragmented architecture, and redundant data systems. Yeah, I've got a client today with 14 different data platforms, right? Now that might be extreme, but more than one is really common. So if you think about what we've been thinking about as the architecture in detail, if you kind of flip on to the next slide here, Wayne, the typical business environment is something like this. On the operation side, you got maybe one system's a CRM, and you have customers, you're focused on who you're selling to, right? You maybe have a legal contract system where you're worried about legal entities, right? You're going to ultimately distribute, and you have to worry about where you're shipping to. And then, you're going to bill, and you need to know who you're going to bill to. And it's not at all uncommon for these to be in different technologies, different architectures, and the data is not always exactly in sync, right? Your sell to the CRM data maybe doesn't exactly reflect who you're shipping it to. And so, I've seen many customers with, like, I guess, some sales operations team in the middle of this trying to kind of sort all these things and make sure all the pieces fit together. I just saw some numbers from Gartner Group that said 75% of organizations have multiple data platforms. And this is the reality, right?
yeah,
And if you flip on to the next one, so what we've been doing as an industry is saying, okay, well, that may be true at the operational level, but we're going to build this data warehouse on top, right? And we're going to run some ETL processes, or ELT or ELTL, TL, because you're going to do gold, silver, bronze, you got transformations at all 3 levels. But we're going to take all the data and we're going to run it through some process, and we're going to build a data warehouse. We're going to often do that overnight. So, you know, separate out the fact that many companies don't have one data warehouse, but even if you succeeded in doing this idealized architecture, your data warehouse is downstream and often 24 hours or 18 hours behind what's happening in operations. And the data that's in your warehouse, where you maybe do some consolidation of that customer data and you get a comment, you do some analytical master data, it's not the same data as what's in your operational systems. So, in today's environment, agents are kind of the hottest thing, right? So, what is an agent? First of all, I think many of you know, but for those of you who don't, it's basically being able to apply a language model along with workflow and the ability to integrate tools into a complex business process. So maybe you have just a language model that's going to help you generate a query, and you're going to even use some RAG capability to help you get a query that already exists. That's great. But an agent might go further, right? So, my example here, sales operations, I've got a customer today says, hey, we got all these people in sales operations. Boy, if we could apply an agent to take on this task, right? Well, then that agent needs to have the consolidated picture of the customer, and they need to be able to update information in the shipping system and in the billing system based on what's coming out of the ordering system. And all those views of customer have to be in sync, right? And so if we're doing the integration downstream in the data warehouse, that's really a problem. And if the data warehouse is being updated, overnight, which, let's be honest, that's what most of them are, well, sales and operations maybe needs to operate in, kind of the flow of business and, realish time, right? And so you got a timing related issue. So one of back to my earlier point about this pressure on the architecture, this separation of the analytical environment from the operational environment, and the idea that we're going to clean up and integrate the data downstream, those are both problems that are going to hinder us, and are hindering us in our ability to implement agents to take on tasks and things like being able to take on operational tasks, like this sales operations person, or maybe you have a CRM process, you got a lot of customers, a lot of orders. You want an agent to look at the analytics of what people have bought in the past and make recommendations on offers when a sales rep is calling on a customer. Again, that agent needs to work in realish time with the flow of the business when the sales rep is engaging the customer, and it's going to use analytics that maybe came from the data environment, and these things need to be in sync. So I think one of the things that is true to my view is that I think one of the things we're going to have to do is we're going to have to bring operational systems and analytical systems back closer together. And if you think about it, Wayne, back when you and I got started, the reason why we put a data warehouse in a separate world from the operational systems, in large part, was because the physical constraints of the hardware of these operational environments. But in a world where we have elastic computing and we have high-speed networking, we actually don't have that kind of constrained architecture the way that we did. And I think that's what's going to cause us to rethink the classic data warehouse model. I don't know,
So,
what's your take on that,
well,
Wayne?
that's interesting. So I want a little clarification. Are you implying that with agents, we may not have to have a warehouse that collects data after the fact in a historical fashion? Or will the data warehouse be kind of the historical repository that the agents might need if they're part of their tasks are to check on the history and bring it back
Well,
into the present?
yeah. So I think that, and I'll talk about a couple companies who are doing this, right, in different ways. But what I think the central view I have is that we can't really have the data warehouse separate from operational systems with a different view, let's call it a cleansed view, an integrated view of data that doesn't link back to operational systems. When we were just going from the operational systems to the warehouse to reporting, we didn't have to connect it. It's not a closed loop. We could work in that kind of environment. But I think that we have to move things closer back together. And I think that people who are implementing agents, particularly people who are implementing agents in that have some analytical driver, they're not implementing the classic data architecture. They don't have operational systems in one world that's completely separate from analytical systems in another world, and some overnight batch process. They have a much more constrained, integrated, kind of architect. And I'll talk
So,
about a couple of companies that are doing that.
so I think what you're saying is that from an analytical perspective, which is where your company lives and where I've been in my career here, you want to create that analytical view or deliver the analysis from the operational systems and kind of break that whole data warehousing pattern that was established 30 years ago, so that maybe you don't really need the warehouse, or it's really truly just a historical archive that's always in sync with the operational. And I
I
do
think
think,
it's, yeah,
go
yeah,
ahead.
go ahead. No, go ahead.
Well, it seems to me that the early use cases I'm seeing for this agentic AI are operational, like sales operations or invoice operations, right? A lot of manual work
Yeah.
that people currently do to keep things in sync and move data from one system to another, right? It's like robotic process automation on steroids, seems to
Yeah.
me.
Yeah, certainly is a lot of that, right? And I think that, I was seeing something from an analyst, just today that indicated that that's the number one use case, but not far behind it are some of these kind of recommendation type functions, right? Where somebody who's taking a sales call or somebody who is, dealing with customer service, or they're actually getting a recommendation into a workflow that is coming from some analytic. And if that analytic is out of date, that can be a problem. So I think that it depends on your use case and how quickly you're going to have to need to move down this path. But my central kind of premise here, which I'm going to kind of talk about an approach to this, which kind of this digital twin type architecture is going to, it's not that you're not going to have aggregations or historical kind of data sets or even high order calculations. Like maybe you want an ROI calculation. Well, that ROI calculation needs the order, it probably needs the cost of shipments, and it needs customer payment information. Those, if they're in separate systems, you can't just say I'm going to build that entire analytic in my order management system, right? But you can build it across a semantic model that an information model that crosses them, and build it close enough to those systems where they
Okay.
are all in sync.
So I think what you're saying is that, to do analytics, which is, your main premise, it's not necessarily going to be done as much anymore in a separate repository dedicated to warehousing historical data. It's going to be done on the fly through the interaction of an agent with all these different operational systems, and they'll build out the analysis
And there may
as
be
we
some
go.
summary tables, yeah,
Yeah,
and there may be summary tables the way you would have in a warehouse. Those may live in a separate platform, but they're going to be connected together, right? They're going to
right,
have the same metadata and the same data architecture. So we're going to have to push that kind of that cleansing problem that we were going to do in ETL. It's got to go back and integrate with the operational systems, and so that the model is consistent across both the operational and the analytical
right.
environment.
So
And the fact that those, yeah, yeah, go ahead.
what you need to picture here in this diagram is that the warehouse may be there or may not be there, but you're going to have on top of all of it a semantic layer that kind of ties everything together that the agents can work off of, because they need
Yeah,
that
that's
level
right.
of metadata to be able to do things accurately.
That's right. They need, they need the metadata. They need to know it's customer, not cust. They need to know the sell to and the bill to, what the differences are. And you're not going to necessarily replace your operational systems to make that work. You're going to go through this kind of semantic layer, which I think now is becoming a critical enabler. And that in itself is kind of different than the traditional data warehouse type architecture.
Right,
And
right.
maybe it'll make a little more sense as we kind of get into some of
Yeah,
what people are doing here, right?
yeah. So I think we've set the stage well to talk about digital twins, but we have one question. And by the way, folks, if you're listening, if you have a question or comment, send it into the chat. So Peter asks, since most companies have multiple data platforms like mine, why don't we start thinking about data virtualization? Is that too complex?
No, I think that there's some level of virtualization is definitely part of this, right? And maybe not the classic virtualization, we're just going to put an entirely new layer on top of all of our data layers. But I actually think that you're right on to something, Peter, which is that uh, it's unlikely you're going to put all those data environments in the same place, right? Now, the fact is that many of these data platforms actually now let you join to data across platforms, right? So you can have a virtual layer. You want your semantic model, if you're coming through it, to know when to, let's say you got some stuff in Snowflake, when do you want to call Snowflake directly? When do you want to call, Oracle? And when do you want to call, let's call it Trino as a virtualization layer where you're connecting data? Or is Snowflake directly connected to Oracle? There's a couple of different architectural ways to make these linkages, but those are physical linkages,
Yeah.
and you have to have a logically consistent data architecture to
Yeah.
make that work. So classic virtualization sometimes just pushes the transformation into the virtualization layer, and you have to push the logical model back across your systems environment. And then how you link those queries, that there's so many different ways to do it. But I
Mm.
do think you're right. I don't think you're going to put all that data. You're not going to say, "Oh, I'm now going to throw out the Oracle system because I need to join it to my Snowflake system and move all the data." It's just
Right.
too time consuming, right, and too expensive.
So what's interesting about the question from Peter is that data virtualization has multiple layers. The top layer really is the semantic layer, which
Yeah,
virtualizes multiple backend systems for the benefit of the user. But now we're
right,
talking about a semantic layer for the benefit of the agent, right? Instead of the
right,
business user, right? Now,
yep,
underneath the virtual layer is, connectivity to other systems, as well as a query engine, right? Now, in this architecture you're introducing, there may be other things besides the query engine and the connectivity to support the agent's workflows and tasks. But definitely, I think you're talking about semantic layers for agents. All
yeah.
right. So
Well,
this,
semantic layers, I think, are going to empower both these cross business
yep,
queries, but they're going to empower agents, right? I mean, you know, in Silicon Valley, right? There's a school of thought that agents are going to take over everything, like next week, right? And
yeah,
and in the real world, there's a school of thought amongst big companies like, oh, wait a minute. First of all, our data is in all these different messy places, and we don't have a semantic model. We don't know how to connect these things together, and and we still don't really know if agents are going to solve these tasks. So I think it's going to take time, but I do think that agents are going to do many tasks. That's my impression. I've been experimenting, and we've done some work with them ourselves. But I think that until you can build a unified model with semantic understanding of the business that at least covers the scope that any agent needs to operate in, you
yep,
can't get there. And you don't want to, and really my kind of, in some sense, the simplest point is, boy, you don't want to physically implement that model because you're back to saying the same old thing, which is to just put all the data together and then, put it all, now you're going to say, put it all together and add all the semantics to it, and
mm,
then we'll do agents. And like, boy, now you're on a really difficult
yeah,
journey. And I think what you see some of the new architectures doing is implementing a semantic layer that can connect across systems, and some one of many different join capabilities when necessary. And sometimes that means like a virtualization tool, like a Trino, and
right,
sometimes it's a direct query, or
yeah,
sometimes now it's even these open table formats. There's so many different physical ways to do it that don't require you to move all the data. And that's kind of the central point.
yeah, absolutely. So we have a few
So,
comments and questions, and then we'll move on to the second part of the presentation. Emerson writes, since data is the new gold, how will we secure and regulate the gold mines with the advent of AI and cloud and DT?
well, I'm not sure what the DT part meant, but I mean, I'm not so much talking today about the regulation, but certainly data governance is critical. It was kind of important in the BI world, and Wayne, I think Wayne is a big proponent of implementing governance models, and helps companies do it. And you needed it but you could maybe get away without it before, but you really have got to do it, when you're going to have agents working in your business. And, so you have to implement data governance. You have to know what is the privacy rights, who can get to what data when. All of that is going to be critical uh, before you can let agents, loose in your business.
I think DT referred to digital twins.
Oh, right. Yeah, got it.
Yeah.
It.
Uh,
Let's
okay.
talk about what that digital twin is, and maybe you got another question you want to jump to before we do.
Yeah, one more question. Can a context-aware semantic layer solve this challenge? Well, I think you're arguing it can, right?
Yeah, I mean, not by magic, right? But yeah, absolutely. And I'm going to give you an example of a company that's done a really interesting thing in taking an agent and using the agent to explore your existing systems and actually generate a context aware model from it that you, yes, have to enhance. But uh, I think that we can go bottoms up, and that's essentially, I'm kind of jumping right into what is a twin. A twin starts bottoms up with what your real world is, right? It's not coming top down with a new model. It's saying, I have a real world, it exists. I'm going to copy that essentially into a twin of that real world, looks just like the real world that exists. And then I'm going to add context to that, semantics to that. And then I'm going to be able to test and implement changes in a micro way that talk to the existing physical system. So the central idea of a digital twin, first of all, it's a virtual replica of a real world system that accurately reflects the behavior of that system. So it is not like in a typical data warehouse. What we've done is we've taken the real world, and then we've made this idealized picture of it, and we've transformed it from the real world to this idealized picture, right? Where we've cleaned it up, we've maybe organized it in a different dimensional form, or whatever architecture we love. But it is not a copy of the actual real world. And so getting from it back to the real world, that's, becomes a problem. What a digital twin is, it's a replica. The good, the bad, the ugly of the real world is what your twin is. And then your semantic layer is going to be identified against your twin as a means to provide that path that integrates the two. And if you do it this way, the twin becomes a means. First of all, twinning is actually easier than what you might think in data systems because you can replicate them. I mean, depending on the technology, or different ways to do it, but you can largely replicate an existing physical environment as the basis for doing this, and you can monitor against that. You can do simulations, and because you started with the actual real world, the path from your analytical environment back to your physical environment is straightforward because you're not having to unwind some transformations or mappings that get you back, right? And that's critical because digital twins are a closed loop between operations, analytics, and back. And that closed loop is the thing that we're going to that's the biggest change in the world that we're heading to.
So,
And I think yeah, go ahead, Wayne.
well, maybe this is a stupid question. I thought where you were going is that we were going to use AI to read the existing systems and generate a semantic layer. Is that something you can imagine AI
Yeah,
to do, right?
That's right.
So
Yeah.
why do you need to create a twin in that case?
Well, because you want to be able to implement, kind of those changes against that physical architecture. The map between the semantic layer and the actual physical systems is, you have to test it against the twin. Essentially, is your means of doing reporting, simulation,
Testing.
kind of
Okay.
things that are outside of the current, right? You can do all these things. You can simulate changes and model them in the twin before you move them back over. But the semantic layer is going to get generated in parallel with the physical, kind of twin. And I think I have a couple of examples of that.
Okay.
And I think I have some examples of people who are doing it. If you, okay, this come next, but why do this? Let's start with this, kind of the classic data warehouse. It's an idealized model. It's not the as is world, right? So, the closed loop becomes a problem. The digital twin models your current data and process architecture. And because you've got things that are physically mapped, you can actually implement much more discrete changes. You don't have to go and do big giant kind of changes. And the that semantic layer, as we've already talked about, it provides this kind of platform for agents and translation to those existing systems.
So the idea is that, okay, we'll create this twin, and then we'll see if the semantic layer that emanates from that actually can suffice to meet the needs that we're using agents to
We
for.
may very well have to go back and make some changes before we start introducing the agents, right? So,
Right, right,
back to my customer model in that original example, if I've got only is oversimplification, right? I only got cell twos in one system and bill twos in another system, and there is no entity structure that brings it all together. Well, I've got to actually create those linkages and push them down so that, so we can make, these kind of linkages work. And in fact, I think I did a webinar about a month ago with Dr. Bob Mack, who's come up with this kind of data compatibility architecture that lets you make those linkages in the operational system without having to go rewrite those systems. And I think there's some things like that that you'll perhaps have to do. But the semantic layer is going to give you a picture of the world. You're going to add your semantics to that picture, and then you're going to identify discrete changes that you want to make
right.
so that the layer connects and that you can then kind of unleash agents, if you will.
So the goal of a digital twin is to create and test the semantic layer and see if any changes need to be made in the physical systems or models that exist already, right?
Both to test the semantic layer and to test your agents, right?
Right,
So
that's the agents, right.
you're not going to just take an agent and throw it into the production environment, right? It's it's a in a sense it's its own complex piece of software, and it's a different approach to software, right? Because it's you know most software that we've all been writing for years is very deterministic. We tell it what to do and it does it, right? It's very rules based in a way. And all language models are they're probabilistic, right?
Right.
And so you're going to have to be able to test your agents before you productionize them. And the twin gives you both a path to being able to build
Right.
a semantic layer and a place to test
Got it.
your changes in your agents.
Yeah, you don't want to unleash your agents on your production architecture and wreak havoc, right? Yeah.
Yeah.
All right. So here's some customers that are doing this, or companies.
Yeah. So it's been interesting to watch some of what's happening in the industry, right? So, some of you may have been reading about and seen about, or even maybe interact with Palantir, right? So we now have a couple customers who've implemented Palantir, and when Palantir sells into a business environment, they don't sell a data platform. And they don't sell an operational system. They actually sell an AI-driven transformation project. But guess what? Under the hood, they have a data platform and they have operational capabilities around it, right? And it's all kind of integrated into a common architecture. And sometimes they actually call it an ontology. Sometimes they actually call it a digital twin. But the reality is it's a process and analytically integrated architecture. It actually uses the data platform is actually Spark under the hood today. Maybe they'll change it or open it up, but the point that's most interesting is not that it's Spark, it's that the analytical environment and the operational environment are all intimately connected, right?
Mm.
ServiceNow, right? They are making a big push into agents, and they actually just made an acquisition this week on the, on the data governance side, and they have been selling us a business operations platform. Well, they're making a big bet on agents and agentic AI to help across these workflows, and they're not doing that by having a separate data warehouse architecture, on top of it. This company called Specific Group. These guys are out of Austria, and they're doing something that's really interesting, which goes to this digital twinning. They basically take an agent, an architecture of agents that they've built, and they can go and point them at an existing system. And initially, that could be some legacy system written in, it's an IBM mainframe written in RPG or COBOL. And, let's face it, the models and the documentation, may have gone away with the developers who have retired, right?
Mm.
Now, you've got some system like that, and you want to agentify some process, right? Well, if you go to, even if you go to ServiceNow, they're going to want to replace it first, right? But if you can actually build a twin of that system with a semantic model, and what they do is they generate the entire semantic model, the documentation, off of the existing system and its twin, and that then becomes a starting point to do forward engineering on implementing an agent. And because their model is very precise to the physical structure of that data, you can now implement an agent that maybe that application is, back to my sales operations example, maybe it's a combination of an order management, system. Then you want the order management process to be you want an agent in there. Well, that architecture is not modern, but if you really have this precise view of the data architecture, you can actually implement an agent that just targets one step in that process without rewriting the entire physical layer that's below it. And I think the kind of thing that they're doing in that respect is going to be really a big part of this kind of move towards agents, where agents can operate on a mixed operational environment. Because both ServiceNow and Palantir, they are replacing your operational systems, right? They are doing that, right? But they are doing it in such a way where the operations and the analytics are together. Whereas, what Specific Group is doing is they're building this twin and this semantic model on top of your existing, physical systems, right? So there's a place for both of those kind of things. Now, what we're doing in Cogenity is we are adding a semantic model to our, data operations stack, and we have already added agents to help build, transformation kind of capabilities, and we would kind of work well with the kind of thing that Specific Group is doing, or really any other data architecture, in building that semantic layer on top of whatever you already have, right? So, as you know, Wayne, kind of one of the central, ways of thinking of Cogenity from the beginning has been, hey, let's support as many platforms. Let's not require everybody to move their data first. But this is a very fast-moving space. I was just in a session today, and I was looking at what Domo is doing, and you could put Domo on this slide, because they are also, and they came out of the obviously out of the data warehouse and BI space, right? And they've agentified, are starting to agentify, some of the data operations and analytic reporting, but they're also, going back and heading towards integrating that back into operations. And I think that you're going to see a lot of vendors doing more of this. And the central thing that's going to happen is that operational systems, analytical systems, they have to have the same models for the agents to exist. And that's going to be a different architecture than, this traditional data warehouse architecture. And, forget Kajani, that's me. Of course, I'm going to talk about us, but take the three companies on top of this list and Domo and, kind of God knows how many other companies are going down this path. They are all unifying their architecture, and it doesn't look like the traditional way that we have done things before.
Yeah. So from what I've learned, AI and agents, they need a rich semantic layer. They need metadata to make wise
Yep.
decisions, when you're automating tasks. So this was a novel approach that you're presenting, but I've heard people talk about, this is going to spawn the use of knowledge graphs and graph databases. It's going to make data catalogs more valuable because they have all the metadata that describes the data in the system.
Yeah.
So I
Yeah.
think there's
I think
probably
semantic models and data catalogs are going to become kind of the same thing, right?
Mhm, mhm.
And we have, but they're going to, so many data catalogs have typically been implemented to sit on top of your analytical environment, not necessarily your operational environment. So these semantic models are going to connect across both of them. I totally agree with you that the semantic model is a graph. You
Mm,
don't necessarily have to put it in a graph database.
right.
You can put it in I mean, what we're doing, we're storing it in Postgres, which is the database under our platform, but it's a graph, right?
Yeah.
And
Yeah.
and language models, and a language model is actually the enabler of an agent, right?
Mhm.
So a language model works really well at understanding graphs, right? It interprets graphs really well and it connects the context. And, it's a little bit of an aside, but I think an important one. I was in a conversation at an event called Data Day Texas, earlier this year, a bunch of data practitioners together. And one of the topics of conversation was, is data engineering going to go away? And had everybody from people thinking that it's going to be like this dystopian world, like Detroit right after the death of the American auto industry. Sorry if you're in Detroit, and I know you're on a comeback, so good for you. Or it's going to be like Save the World, right? And what I see is that when you and I, Wayne, started in this business, we were building data models, right? As part of implementing systems, right? We did data modeling, we did semantic modeling, and that became a lost art. And I think what's going to happen now is that actually it might be less important to be a great Java programmer than it has been here in recent times. Not Java programs are not going to go away, but I'll tell you one thing is definitely going to become more important. The way it was 20 years ago, it's going to become more important. Is we need modeling expertise, right? Data
Oh,
architecture, semantic modeling. This is a skill set that's going to come back, and that skill set, if we model things effectively, it then can drive the development of the software, right? So we may code things more using agents, but we got to have a model. And the model represents a domain understanding of the business.
yeah.
And that's going to require modeling expertise.
Well, that's fascinating. That's fascinating. We'll return to the basics in a whole different context. That modeling reigns supreme. And I get it. It's AI needs a model, needs the metadata to understand and give you accurate answers. It's just like with these small language models, people are training those on specific domains of information to improve the accuracy and ability of those large language models to deliver accurate answers, right? So,
Right. Right.
so this is
And
just
those are great, but they are domain general. They're
yeah,
not your domain. They're not your business, your organization, right? So, your organization, customer ABC, you've got your own domain model, right? Which is related to the industry domain model. And you need a semantic model that represents that. And that's going to empower AI.
yeah,
And you don't want to have to implement that semantic model by physically replacing all of your existing stuff first, because you're going to be doing that while the rest of the industry has moved on and already
Yeah.
agentified, their
Right.
stuff. I think that the reality is that this world, we now have to recognize that one central data platform, one central system ain't ever going to happen.
Yeah.
And
We've got a few
this
questions and
semantic, yeah,
comments.
go for it. Okay. Yeah.
Yeah, and just one comment from me is that given that scenario, you could actually create multiple models on the digital twin, right?
Sure.
Depending on what use case you want to apply the agents to, right?
That's
And
right.
those models will be tuned to specific use cases, perhaps, right?
Yeah.
Yeah,
Yeah.
either
This is
way.
one of the things that we support is
Yeah,
what we're going to support in our stuff is going to be multiple semantic models,
nice,
right? Because, that's, I think that's exactly going to be true.
cool. All right, Sanjay asked, "Will this double my infrastructure costs?" Good question.
Double is what?
Infrastructure costs.
Well, it's a real question of how much are you going to have to pay for the agents to operate, right? And it's one thing to think I got a team of 50 people in sales operations, and I'm going to agentify it, and so I'll need 3 people instead of 50. I'm making these numbers up, so don't hold me to it. To work with the agents, you're like, well, am I just reducing my headcount by 47? Well, maybe, and that's a really extreme example, by the way. Uh, but you are also adding cost for the model processing, right? So it's not just as simple as I did this giant productivity headcount reduction, because these model costs are also real, and they are also part of the equation of figuring out, how much of these costs. And to what you said earlier, Wayne, it's also, this is one of the reasons why people are going to small language models, right? Is because if you could use Chat GPT 4 or whichever one. Giant model has the history of the world in it, right? But if you're trying to do sales operations, or you don't probably care about the history of Greek society, and you don't want your model to have to as interesting as that might be, to have to process through that. So small language models, they're domain specific, with your own semantic layer, probably are going to help control that cost. But the cost of processing is real. It's a good question, Sanjay. And yes, it's going to increase the cost of your infrastructure. But you have to see to what extent is that going to offset the productivity gains
Yeah.
from using agents, right?
Okay, so one more question, then we'll move on. We've got a few others too. But is the testing of changes in a digital twin stored all in memory, or is there a storage layer to capture iterative changes to the data architecture prior to releasing a tested use case?
Yeah, I think it's physical, right? So the semantic layer, is a logical representation. I mean, even that's stored somewhere. But the twin is a physical, replica. In a sense, it's a different way to go about your old dev test production, right? The twin really kind of replaces test, right?
Yeah.
And it is a physical set of systems. The twin is, with a
Okay.
limited set of data, right?
Okay, so we'll keep moving on here. You've got your twining architecture or twinning.
Yeah. Yeah, yeah. Sorry. I'm often critiqued for good reasons about my spelling, which is terrible because I'm dyslexic as heck. But so just to kind of think about what I've said here, I tried to put it into a diagram, and I'm not the best diagrammer in the world, but you have your existing system, you implement your twin, right, which is a physical system. From your twin, you build the semantic model. You're really building the semantic model off of both your, because the twin is just a copy of but you're building your semantic model, and then you're going to use the semantic model to figure out what simulations and changes you want to make. You're going to make those in the twin environment, right, and test your simulations, test your agents, and then when you're happy with them, you'll take the last step, which is to push them back, which is the next slide here, into production, and then that red becomes black, and it's part of this kind of closed loop, system, right? So
Cool.
you could say, it's like I actually, I talk about this kind of idea set with my own CTO, and he has some things he questions in it. And I think that, I suspect if we just had just some giant conversation, others would. But I'm going to kind of say that this idea is the twin is the copy of your environment as it is, right? It's not like a classic data warehouse that is just an idealized picture. That allows you to close the loop back from the changes that you make to implement in production. The semantic layer is critical because your agents have to talk in language and semantics to your physical structure. And so I feel like those two things are just truths that are going to be, like every time I rethink this or, think, am I crazy? I come back and I say, well, are those things true? And I think they are true. That, in order for me to close the loop, I need to be able to have an environment that reflects the real world. And I can't be doing transformations downstream that aren't reflected back upstream. I think that you can't get around that. And I think that you can't get around the idea that you need a semantic model to represent the business logic, which is a graph of your business information that your language models are going to talk to. And that's where I think we're headed. I think there is a tremendous amount of innovation in this space. I think that, we see some of the firms I mentioned and others who are doing some of the innovation here. But I suspect, kind of, I don't know, I'll just jump 10 years ahead. I think 10 years from now, the data architecture that we've been based on for 30 years of operational systems, idealized model, data warehouse, updated overnight, supporting analytics. I don't think our world's going to look like that. That's what I'm saying.
Rick, you're prophesizing blowing up the status quo. You'd be a good political radical.
Yeah, we could talk about that, but yeah, I've never been one to follow the existing thinking, and whether I'm right or wrong, you guys can all kind of decide. But so the way I think you end up thinking about this is, okay, well, like everything, you need to start with your value hypothesis, right? So doing AI and agentic AI is not just going off and exploring whatever, and you really need kind of an entire AI strategy where you have introduced governance, as I think it was talked about earlier. You need to have some decisions about what kind of tools, et cetera, that you need to deal with. But doing all that, then you have to establish where the scope is. Then you can twin your environment, right? And that's where you're going to kind of copy and reverse engineer your model. That's where I think you can use these agents, things that are out there and coming to help build you that twin. And then you're going to enhance it with additional semantics. And then you're going to be able to implement these critical improvements that make the connectivity and solve quality, data compatibility. And that then is going to be the foundation of building your agentic future.
Hopefully the twin doesn't reveal that your system's architecture is so screwed up that it doesn't make any sense to implement agents. They'll just get lost or wreak havoc.
Yeah.
I mean,
look, you and I have been in this for a long time, and I think everybody who's on this call is probably a data practitioner, and we recognize how complicated many of our business systems environments are, which is right. I think why the Silicon Valley people, they all look at the power of what their agents are doing and how much progress is being made with the technology. They go, oh, we're going to take over the world. But those people don't live in the world of operational systems that have been implemented over the past 20 years in some big company, and they have 6 generations of technology and all kinds of technical debt, and so it ain't going to happen overnight, in my view. But I think it's going to happen, and I think this kind of some of these new ways of thinking are going to be part of that.
Good. A couple of people are asking for a reference architecture. I think this diagram is probably very, very high level reference architecture.
Yeah, and if kind of what I would say is have them capture their emails. I'll happily share a little bit more detail because I actually have a more detailed picture of what that might look like. And I'd happily share it with everybody on this call if they're interested, but certainly with those who ask.
Yeah,
It's like this, but more, right?
we can, we send an email out to everybody who registered. So if you
Yeah,
want, Rick, you can send that link to me and we can send it out to everybody.
yeah, great. It'll probably take me because I'm traveling for the next week, but when I come back, I will share that, Wayne, with you, and we can share it out with everybody here. And I hope that this is interesting.
So we got
And
like,
by the way, yeah,
go ahead.
if somebody thinks that I'm totally crazy, I'm willing to hear that too. They wouldn't be the first, and I'm happy
Well,
to hear
I
contrarian
would like
views.
to hear from our audience what they do think about this idea. Obviously, it's in very early stages. So if you want to put something in the chat, that would be great. Or just contact us via email. So we have about 2 minutes left. I noticed on this slide, you mentioned business process. That's something we haven't talked about in this session.
Well, that's part of the twinning, right? So you're not just twinning the data model, right? You're building a business process model as well. And what I talked about with SPG Group, they're doing both. They're generating a data and a process model because and that process model is critical because if you are going to make very specific changes, you got to know which processes you're impacting, right? So it's a data and a process model that is part of that semantic view of the business.
Got it. Okay. Great. Well, we had a pretty active audience. Thank you all out there. Would love to hear your opinion on what you heard today. So please don't be shy. Send us your comments now or after the fact. Rick, really want to thank you for bringing this topic up and presenting it. It's still early days, but I think you got a lot of people, including me, thinking long and hard about how this might work in a real environment where people are serious about implementing agents and AI.
Yeah. Great. Well, Wayne, thank you very much. Always great to talk to you, and thank all of you who sat in and listened to this today. And happy to chat with anybody who wants to talk more.
Great. Have a great day,
Have a
everybody.
great. Yeah, you too. Bye for now.